My dear students, other viewers and listeners, I, Professor Manohar Lal, School of Computer and Information Sciences, welcome you to this lecture on uncertain knowledge and reasoning. Especially will focus on fuzzy logic, why and what. Friends, before I go into the details of the subject, I like to tell why we study whatever is going to be discussed today. Friends, the topic falls under artificial intelligence. Artificial intelligence is meant to solve hard problems, especially which are exponentially hard, by exploiting the knowledge of the domain under consideration. Hence, knowledge plays a very important role in solving problems through AI tools and techniques. Rather, it is said that knowledge is fodder of artificial intelligence or even general intelligence also. So friends, in this context, the role of knowledge is very important so far as solving problems with the tools and technique of artificial intelligence is concerned. Now, within that, why we study uncertain knowledge and reasoning and particularly fuzzy logic? The reason is that the knowledge whatever we get is uncertain on the basis of the following facts. Number one, that whatever is stated as a fact it generally is a sort of belief. Earlier the earth was thought of as the center of the universe. It was a belief, and on the basis of this a number of problems were solved. However, later on Galileo and others told us that earth is not the center of the universe. Rather, earth is revolving round the sun and so on and so forth. So we have another set of beliefs. So whenever we advance in our thinking, we have newer and newer set of beliefs. We cannot say with surety that this is a fact, this is a set of facts. So most of the time whatever we are reasoning, whatever we are solving problems with is generally a set of beliefs. And beliefs are revisable, as I told you just now, that earlier the center of the universe was thought of as the earth. It was later on revised, and it goes on. Similarly, in our everyday experience, when we get better and better experience, we revise our beliefs which get sharpened, and those get sharpened in order to solve problems better. So friends, the very first thing of uncertainty in knowledge is our beliefs, because those cannot be certain. Secondly, when we are dealing with other things like mass phenomena, for example, when we say an Indian is of height 5 feet 6 inches. Now, height of the person is a variable which varies from person to person over billions of people. So in such cases, in order to have a general idea whether an Indian is taller than an American or a Chinese or not, what we do, we take some sort of average over the people concerned, over a mass phenomena, and in this way we say, for example, the height of a person, an Indian, is 5 feet 6 inches. Actually we mean here that the average height of an Indian is 5 feet 6 inches, and if we go to measure the height of various people, I think none may be having height 5 feet 6 inches, but the average comes out of that. This is the second reason of uncertainty in the knowledge, because when the mass phenomena is involved, in that case we have to represent the masses by single numbers, etc., and that tells us to approximately represent by average or something like that. The third cause of uncertainty in knowledge is that we are using natural languages for communication and other purposes. Language is a very strong tool with the human beings because that makes us the distinct from the other species, living species like that. Language is a strength, and language, particularly natural language, have another strength, that just by one word we may be denoting a number of concepts. For example, we take the concept of tall. Now, a person in Indian context who is, say, above 5 feet 10 inches or so may be called tall. But then a person of height 5 feet 11 inches, a person of height 6 feet, and a person of height more than 6 feet is also tall. So in this way, the single word tall represents a number of heights each greater than or equal to 5 feet 10 inches. Similarly, there are everyday other concepts or adjectives, for example, sweet, beautiful, and so on and so forth. Now, the use of these words is definitely a strength, but at the same time it inserts an uncertainty also, in the sense, when I say Mohan is tall, it inserts an element of uncertainty, in the sense we cannot say whether Mohan is 5 feet 10 inches, whether Mohan is 5 feet 11 inches, whether Mohan is 6 feet, or Mohan is more than 6 feet. On one hand, the use of tall is a strength in the sense that single word tall denotes a large number of heights. On the other hand, when solving a problem with the computer system, it creates a problem because such words, which are actually linguistic variables, that is, they are variables, they may assume different values and all that, have to be resolved in some situation. The uncertainty because of such linguistic variables may require to be resolved in some situations, and in essence, I have told you, whatever I have said, I just briefly summarize, that in order to solve difficult problems, we require knowledge. However, the knowledge whichever we use is generally based on the basis of beliefs which are revisable, on the basis of averages, in the case of mass phenomena which are also not precise, and thirdly, we use linguistic variables like tall, hot, sweet, etc. So all these reasons tell us the knowledge which we are using in solving problems is not certain, and therefore it is very important for us to study the uncertainty in knowledge, number one, and number two, how to formalize it, how to express it in mathematical concepts like sets, numbers, relations, functions, etc., so that the computer also can simulate the human behavior in solving the problems, because computer can work only on those concepts and on those operations which are directly or indirectly mathematical in nature. So we have two goals, because of which we study uncertainty of knowledge and reasoning, because most of our knowledge is uncertain. However, it needs to be formalized in terms of mathematical entities like sets, relations, and functions in order to be operable by computer systems, because it is a man-machine combination which solves problems. Man, on one hand, perceives the problems, number one. Number two, it also plans the solution of the problem. That is, what steps are to be executed by the machine are also thought of by some human being at some stage and are embedded in the machine. And this also raises the question, then what is the role of the machine? What is the role of the computer system? If it is the human beings which solves the problem, at least the plan of the problem is given by the human being because of the executional speed. Computers are used mainly because the speed of the computer systems is much, much faster as compared to that of human beings. So this man-machine combination solves problems, and we know most of the knowledge which is experienced by human beings, is to be embedded in machine, and machine requires the embedding in terms of mathematical concepts like numbers, sets, relations and functions. So friends, with this background, let us come to the precise details of our today's talk. What is the role of knowledge in solving difficult problems? I may again emphasize, I may recall briefly, that the usual technique of solving problems in computer science is algorithm. However, during 1930 and 1940 it was proved that only a very small fraction of the problems which we human beings encounter or may encounter in the future also, only a very small fraction of such problems will be solvable with algorithmic means. And therefore we have to take resource to other methods which may not be just purely algorithmic. Then it was found out in the very beginning, in the initial stages of the computer revolution, that knowledge is an essential component, as I mentioned earlier also. So in order to solve those problems which are said to be hard problems, that is, which take much more time as the size of the problem increases, which may not be responding in reasonable amount of time, and many of those may not be solvable at all with the computer systems. For such problems, if we exploit the knowledge of the domain under consideration, then some of those may become solvable. So that is exactly the role of knowledge in solving problems. The next slide says that the knowledge may be complete and may not be precise, etc., because of the fact that universe is vast, and secondly, it has changed over billions and billions of years since the birth of the universe. So the change has inserted element of uncertainty, because the change is infinite dimensional almost, and the universe is too big to comprehend for us. So because of that, the complete certain knowledge is impossible, and this is why we study the topic of uncertain knowledge. Uncertainty types include, uncertainty may be of three types mainly. One is epistemic, the other is probabilistic, and third is fuzzy. I have already given an example that epistemic means degree of belief. As the next example says, that Mohan believes that an American is tall. Now there are at least three words which insert some uncertainty in the statement Mohan believes that an American is tall. First of all, believes. We don't know how much is the strength of belief of Mohan. Mohan may be partially believing. Mohan may be just believing. Mohan may be completely believing. So there are shades of belief, shades of degree of faith of Mohan in the statement which is being made. Then the next is American. Now here also, American is again an imprecise word so far as tallness is concerned. Some of the Americans may be even 7 feet tall. Some of the Americans I have seen myself are less than 5 feet also. So what I mean to say, American in itself is an uncertain word vis-a-vis height of a person is concerned. Then tall. So I have already explained the word tall stands for a large number of heights. So there are three words. The first, belief, is a sort of epistemic uncertainty. The second, the American, is a sort of probabilistic. And the tall is a sort of fuzzy uncertainty of knowledge. I hope you have understood the difference between various types of uncertainties which we may encounter, and these uncertainties appear in the language which is used to express our ideas, which is further conveyed to the machine, and these uncertainties have to be conveyed to the machine in a language which is understandable to the machine, and machine understands mathematical concepts, operations, relations, functions, etc. In this talk, we will be discussing the intrinsic concept of fuzziness with examples, Then we'll be discussing fuzzy rule. Then I have already explained why fuzzy. Then definition and example of fuzzy sets. Then we'll discuss operations on fuzzy sets similar to crisp sets, and the new type of operations on fuzzy sets. And then we'll discuss what is meant by fuzzy relation. Then we'll discuss what is meant by fuzzy logic. Now I come to, first of all, discussion of fuzzy concepts, relations, functions, etc., which surround the concept of fuzzy. So friends, first of all, I gave examples of sweet, I gave example of tall, I gave some other examples also. I told that each of the words is actually not standing for something certain, but a large number of things. Think other words of natural language. Healthy. Now first of all, it is very difficult for us to tell who is healthy. What are the parameters of health? Then even if we know the parameters of health, we don't know what values are exact values by which we can say a particular person is healthy or not. So healthy actually incorporates a very wide spectrum of concepts in which the temperature, the blood pressure, and so many other entities, the functioning of the heart, the functioning of the kidney, the functioning of the liver, all these vary from person to person. But within a range, if the values are there, if the heartbeat is within some particular range, if the blood pressure is within certain range, I underline the word range, not a particular specific value. So when a range is there, which stands as a value for a person to be healthy, then it becomes not a precise concept but imprecise one. Similarly, old, young. Now, when a person is, say, below 20 years, we say, yes, the person is young. A person who is, say, about 70 years old, we may say with definite the person is old. Day by day, we don't know when we have become from 20 years to 70 years, when we have actually become from young to old. It is not all of a sudden, overnight, over one day, or by just addition of one day, one becomes, no, it is a gradation. So you cannot say that at 35, one becomes all of a sudden, when one day is added, becomes old from young. So these are some of the words. Next, sweet mango, I have told you. Again, if you take a cup of milk and put one small sugar cube, then you go on adding, and after, say, 100 small particle cubes, it becomes sweet. But it is not the 100th, the last particle cube, because of which it has become sweet. No, the sweetness has increased gradually with addition of each particle. Similarly, beautiful painting, it is hot and humid. We cannot say it becomes hot exactly when it crosses 40 degrees. From 20 degrees centigrade to 40 degrees centigrade, the hotness increases gradually. So hot word indicates a wide range of temperatures, maybe say from 30 onwards or like that. But you cannot say just by addition of 1 degree something becomes hot. No, it is gradual increase in the value of hot. The vegetable is not properly cooked. Now, the not properly again is an uncertain word. So friends, I told you how the uncertainty of language appears in our thinking. Now the next step is, in the case of classical set theory, either a person is young or not young, either the milk is hot or not hot, either a person is beautiful or not beautiful, because in classical set theory, which we call crisp set theory, either an element is a member of a set or not a member of a set. So the conventional or crisp set theory is not able to handle such concepts as healthy, old, sweet, etc., etc. So we'll have to find out the alternatives. And what may be the possible alternatives? Fuzzy set theory, relations, function, etc. are just providing a tool or mechanism to handle this type of entities like healthy, old, etc. with mathematical tools. And what are the mathematical machinery or tools developed for the purpose of handling such imprecise concepts? That is, instead of assigning only two values for an element so far as its belonging to a particular set is concerned, belongs to, and the second value is not belongs to, instead of these two values only, we say that instead of assigning just two values, which you may call 0 or 1 also, we assign a range of values in the range of 0 to 1. When old is under consideration and if a person is of age 70 or above, we assign a value 1. That yes, definitely the person with an age of 70 or above is an old person. Again, if we take a person of 20 years old, we assign a value 0. That is, according to the common usage, a person of age 20 or below is definitely not old. So in this case, we assign a value 0 to a person so far as oldness is concerned of age less than or equal to 20. And then we gradually increase the values in the range of 0 to 1. Instead of saying old and not old, we say a person has a degree of oldness in the range of 0 to 1. For example, a person of 30 years may be assigned a value of 0.2. A person of age 40 may be assigned a value of say 0.45. A person of age of 50 may be assigned a value of 0.7. So in this way, the fuzzy set theory handles the linguistic variables, which I told are essential component of our everyday language, which appear in the problems which we encounter and in the solutions which we propose. I hope now you understand why we study fuzzy logic. I take some other examples. These were not healthy, etc. were not even the range of values which were denoted by some other phrases like for a long period. You will see that the word long period may stand for from 6 hours to millions of years. Dinosaurs ruled the earth for a long period, and here for a long period, the phrase for a long period stands for millions of years. In the second, it has not rained for a long period. Again, for a long period is appearing in this second sentence also, but this for a long period doesn't stand for millions of years. It may stand only say about 6 months. And I had to wait for the doctor for a long period. And here it can't be even for 6 months. Nobody waits in a doctor's room for 6 hours, 6 months. Rather, it may be 6 hours. So friends, what I want to convey to you is that not only the adjectives, but other phrases also have different values, and the values may vary from a few hours to millions of years depending upon the context. So one of the ways of resolving the ambiguity, the uncertainty, the imprecision about a particular phrase is the context. When it is being talked about the dinosaurs, in that case, it may be standing for millions of years. When it is talked about rain, it may be a couple of months. But when it is in context of waiting in a doctor's room, it may be standing only for a few hours. So we human beings have the strength of resolving this ambiguity or imprecision depending upon the context. Now how to embed this in the machine, as I told you just now, is through the use of range of values from 0 to 1, as I explained in the case of talk. Not only it is fuzziness is only in the linguistics, even the fuzzy rules. If an obstacle is close, then apply brakes immediately. Here the two words, close and immediately, are not precise. If the vehicle is running very fast, maybe say 100 kilometers per hour, even 50 meters or less may be close. However, when we are moving on a bicycle, Even 2 or 3 meters may be close, and beyond that may not be thought of as close. What do you mean by immediately? Again, immediately may mean a few seconds, or it may mean a few minutes, or it may mean even more than that, depending upon the context again. So what I mean to say, it is not on the linguistic variables which are appearing only as the statements. These may appear also in the rules which we use in our everyday context of solving problems. One very strange thing which we'll find out is that we human beings are really very good when we talk in terms of imprecise concepts. Rather, sometimes we are baffled if too much precision is embedded in our talks. For this purpose, let us take an example. Partially clouded sky, then saying 39.77% of the sky is covered. We prefer the statement that the sky is partially clouded, instead of saying that the sky is 39.77% covered. What does this indicate? Though the partially clouded is having imprecision, it is not a very precise phrase. It is much less precise as compared to 39.77. However, if somebody says that the cloud cover is 39.77, we may not get the intended meaning at all. However, instead of that partially clouded is used, we get the intended meaning. What I mean to convey here is that most of the time, we the human beings feel more comfortable when imprecise words or phrases are used as compared to precise numbers or figures. I hope this idea is very clear. Now, but on the other hand, the computers are comfortable with precisions. That is what it means in other words is that the human beings are better at qualitative processing, where the machines are better in quantitative processing. Whenever the precision is there, the precise numbers are there, even if these involve 10 places after the decimal, still the computer will be not baffled. But we human beings are baffled if something says that the sky cover is 39.76543, etc., etc. It becomes more and more difficult if more and more precision is embedded in our statements. It is a paradox. And now, what is the implications of this? The implication is, as I mentioned in the very beginning, that it is not the computer system which solves the problem. It is not the human beings which solve the problem. I again recapitulate what I said earlier, that the problems are encountered and perceived by human beings, number one. Number two, the plan of the solution of the problems are again thought of by human beings. These two parts are handled by the human beings. On the other hand, the third part is handled by the machine, that is the execution of the plan because of its speed. The computers have marvelous speed. What is its implication in context of what I've said just now? I just now said, we human beings feel comfortable with imprecise statements. The machine is very comfortable, or whatever is good at processing when it is precise statements are used. So what is there is a gap in the underlying capabilities of machine and man. How to bridge that gap? That is, the human being think of the plan, they think in a natural way in terms of imprecise words and phrases, etc. On the other hand, these ideas have to convey to the machine because machine is very fast in executing the solution, which is good at processing exact entities, quantities. And for that, one of the via medias, there are various via medias which have been found out to bridge the gap of imprecision-based quality of human beings and precision-based qualities of machine. Through one of the tools or techniques or mechanism is fuzzy logic, fuzzy sets, fuzzy reasoning, fuzzy relations, etc. So, repeatedly I am telling you, what is the significance of study of fuzzy? I have given more examples on the slide. where I reiterate that human beings are good with imprecision, where the machines are good at precision. Just by looking at the eyes only or nose only, we may recognize a person. Just by taking and feeling a small number of grains from the cooking rice, we can tell whether the rice is properly cooked or not. Just again it is imprecise. Sometimes only the rice which you take may be well cooked, but the rest of the rice may not be cooked well. But in most of the situations, it works well. So here again, what I mean to say, that it is the imprecision on the basis of which we work or solve problems most of the time. However, these solutions are generally good solutions, may not be perfect solutions. There is a difference. The machines, if they give a solution, will be a perfect solution, whereas we human beings, which work most of the intuitions, are able to give good solutions in most of the situations, but may not be the perfect solutions. I am emphasizing repeatedly the importance of study of fuzzy concepts and all that. The concept of number, the concept of set, and all these are precise concepts which we used in expressing our problems to the computer system so that it solves the problem in terms of strengths. And the strengths of the computer are precise entities, the numbers, the sets, the relations, functions, which I am talking in terms of crisp sets. Crisp sets are those sets where if you take any element in the universe, you only can say either it belongs to it or does not belong to it. However, as I mentioned, generally we don't do like that in our everyday life. A tall person may be having any height from 5 feet 10 inches to anything if we take, say, Indian standards of tallness. So, again, how to convert the entities which are imprecise in terms of numbers and sets of crisp sets which are precise in nature. You may have an example of a precise statement and imprecise statement. Once again, in order to know the difference between what is precise and what is imprecise, if income is more than 2.5 lakhs, then the tax is at the rate of, say, 10%. Whereas the imprecise statement may be of the form, if the forecast about the rain being slightly less than the previous year is believed, then there is around 30% probability that the economy will suffer. You can see the second statement, the forecast in itself is imprecise, then is believed, as I told you, the belief's degree. Somebody may believe something completely, somebody else may not believe more than, say, partially, and so on and so forth. And then the 30% probability. What does this 30% probability means? That on the basis of the previous experience, having taken statistics of hundreds of years, we know if the rain is less than 30%, then the average, then it may be damaging to the crops, etc. So everything in the second statement is having imprecision, but we human beings are very good still in working out a solution. Whereas in the earlier statement, if the income is more than 2.5 lakhs, then the income tax is at the rate of 10%. Everything is very precise because those are in terms of the numbers, sets, relation, functions of the crisp nature. So with this emphasis between the precision and imprecision, the basic qualities of the machine as the human beings, we go to now the next statement. In order to explain the fuzziness involved in the linguistic variables, we will take help, as I mentioned, of the crisp sets. So how do we do? How do we go about it? Though I mentioned earlier, but still, just for further illustration, I again explain how the imprecise concept of tall will be expressed in terms of precise concepts of sets, membership, numbers, etc. Please look at the imprecise concept of tall. We can say that a person is definitely tall if the height is more than 6 feet. Not at all tall if the height is less than 5 feet. We are talking in context, Indian context. If the height is 5 feet 2 inches, then the person may be said to be a little bit tall. If the height is equal to 5 feet 6 inches, we may say slightly tall. If the height is 5 feet 9 inches, we may say the person is reasonably tall. Now again, in this description, we have used natural language words. Definitely, not at all, a little bit, slightly tall, reasonable tall. Now what is the next? At least we know some difference, qualitative differences between definitely, not at all, a little bit, slightly, reasonably. We know the qualitative difference between these. Now how to express this in terms of mathematical entities? We can convert these linguistic imprecise words, though relatively comparable. You know, definitely is always taken more than reasonably. Reasonably is taken always more than slightly. Slightly is taken more than a little bit. And a little bit is taken more than not at all. And so, we have already a sort of comparison relation between these words. Now once we have intuitive feeling about this, we can convert it to the mathematical numbers. The next problem is not very difficult, as you can see. Now what we can do? We can say that a little bit may be taken as 0.2. A slightly tall may be taken as 0.4 in the range of 0 to 1. That is, when a person is not at all tall, if the person is less than 5 feet, we can say the value assigned so far as tallness of a particular person is concerned is 0. But when we are saying a person is about 5 feet 2 inches, and according to our definition we say the person is a little bit tall. So we can, but little bit is more than not at all, and therefore the value to be assigned to of tallness to a person who is a little bit tall should be more than the value which is assigned to a person who is not at all tall. And not at all tall has been assigned a value 0, therefore a little bit tall person should be assigned a value which is greater than. And we say hypothetically, not a very precise, in every situation, we may say that the value which we associate with a little bit tall may be assigned as 0.2. Maybe, I am saying. And when a person is, say, of 5 feet 5 inches, and according to our criteria the person is called to be slightly tall, and in that case we can say the value which is to be assigned to a person which is slightly tall should be more than the person who is a little bit tall, and the value may be assigned more than 0.2, and in this case we assume that let it be 0.4. Then what is that? Then a person is, say, 5 foot 7 inches, and we call a person is reasonably tall. And a reasonably tall person having more height than a person who is slightly tall. And a person who is called slightly tall has been assigned a value of 0.4. So we may assign some value greater than the value which is assigned to the linguistic variable slightly tall, which was 0.4. Let us assign a value of 0.7 and so on and so forth. So friends, first of all, I have discussed the mechanism of how to convert linguistic variables to precise numbers and sets. As the word tall is an imprecise word, but then it has been further categorized into, according to the heights, as not at all tall, a little bit tall, and so on and so forth. And then there is a gradation between these linguistic words, not at all, slightly, reasonably, definitely, and that gradation should be preserved in terms of numbers of the range of 0 to 1. This is the mechanism which is followed in converting imprecise words of natural language to precise numbers and sets. So once we know the mechanism for converting imprecise concepts of the everyday language or natural language to the language of mathematics, next, how the computer should operate in order to solve problems. So friends, in the rest of the lectures, it will be mostly mathematical treatment of fuzzy sets. In the case of crisp sets or the normal sets, there is a notation. The curly brackets are there, and within that you write the elements separated by commas. For example, you have the set of rivers flowing through India, then you may write the first curly bracket, then you will write, say, Ganga, comma, Yamuna, comma, Godavari, comma, and like that. So what will be the notation for the fuzzy sets? We have definitely associated degrees with various heights in the range of 0 to 1. And because we have to operate in order to solve problems. So what will be the notation for a fuzzy set? For this purpose, we take an example of 5 persons. 5 persons are Mohan, Sohan, Johan, Abdul, Abraham. Their respective heights are 5 feet 2 inches, 6 feet 4 inches, 5 feet 9 inches, 4 feet 8 inches, 5 feet 6 inches. So friends, as we have already agreed to associate some numbers with these heights, and these heights are associated with persons, so we will be able to associate some numbers in the range of 0 to 1 with the persons now. Now what will be the advantage? First of all, you see the advantage of this fuzzy notation is that had we talked only in terms of crisp sets, and according to our definition, only Sohan, who has 6 feet 4 inches height, is the only tall person. So if we talk in terms of our conventional sets, then we'll say the set of tall persons is equal to Sohan. However, if we use the fuzzy notation, as you'll see from the next slide, you can see now everybody appears in the set, because Mohan has height 5 feet 2 inches, and we have said that Mohan is a little bit tall, and little bit has been associated a degree of 0.2. So Mohan is now associated degree 0.2, and it will be written Mohan slash 0.2. Sohan, who is 6 feet 4 inches. And according to our definition, a person of height more than 6 feet is definitely tall, with which and with definitely tall we have associated a value 1. Therefore now Sohan slash 1 indicates that Sohan is definitely tall. Johan, who is say 5 feet 7 inches, and with that height we have associated 0.7. And Abdul, who is 4 feet 8 inches. And according to our definition, any person who is less than 5 feet is not at all tall, and with not at all tall we have associated the number 0. And similarly with Abraham we have associated 0.4. Now main point which we should pay our attention to is that now the concept of tall has been expressed in terms of a set, because the curly brackets are there, the commas are there. Only difference is that now the elements are composed of 2 parts, Mohan slash 0.2. Now Mohan slash 0.2 is one element of the set. Sohan slash 1 is one element of the set. Johan slash 0.7 is one element of the set. And in this way, all the human beings which are under consideration appear there with their respective degrees of height. And once this is done, it becomes a mathematical entity. Now this is also a set, which is a crisp set, which is the conventional set which you have studied so far. Only the elements are a bit different type. Mohan slash 0.2 is one single element. And you will see the advantage of this in solving problems. So first of all, I draw your attention to the fact that the fuzzy concept, the imprecise concept of tall, from which you did not get a unique idea, has been associated a set which has definite meaning. This is a first big achievement. Actually, Zadeh, a great philosopher, mathematician, he generated the idea of fuzzy in 1968. And earlier the fuzzy was not a very popular concept even among academicians. Later on, Japanese actually used the fuzzy logic in their machines and all that, and from there the fuzzy theory, etc. became very popular. And you'll see the use of this nowadays. Your machines have fuzzy logic operating machines and all. So how it operates? We in an academic discipline are not to be dazzled by the technology, but we have to find out the reasons how it functions the way it functions. And that is the purpose of study of any academic discipline. So we'll see how the machines or the computers are able to function with the associated definite concepts of sets in which the elements have 2 components, namely the name of the person, and in this particular case, the degree of tallness. In the rest of the lectures, we will concentrate on whatever operations are there in crisp sets, which you know, intersection is there, union is there, complementation is there, etc., etc. How those operations are carried out on the sets in which the elements are not just ordinary elements, but they contain two components. One is the name of the person and the second component is the associated degree. How we get the associated degree through various mathematical operations, this is what we are going to discuss in the rest of the lecture. What is the complement of? First of all, we have to think at intuitional level, because that is very important. If we are not able to make the correspondence between the intuitive notions and the formal notions of mathematics, it is not possible to use the fuzzy logic. So here, you know what is the complement of tall? The complement of tall is short. And more a person tall, less the same person is short. So vice versa. So what our intuition says? Our intuition says if the degree of tallness is more, then the degree of shortness should be reverse of that. I hope that is very clear. So by using this reasoning, intuitive reasoning, we get the definition of short, that is whosoever has degree say point x, you get the degree of shortness as 1 minus point x. So here we get that Mohan, who has tall degree 0.2, should have degree of shortness as 0.8. So one who is definitely tall should not be at all short. And the degree of shortness of Sohan, who is 6 feet 4 inches, should be 0. And similarly, you can find out the degrees of the other elements by subtracting from 1 the degree of tallness in order to get the degree of shortness. And what is this? This is your complementation in mathematics. That is, you know that the set of tall union the set of short is equal to the set of all human beings. And therefore, what is set of short? It is complement of set of tall in the universal set. But first of all, you must understand it at the intuitional level. Once you are able to make the correspondence in your mind, then it should not be a problem for doing the rest of the things. So friends, equality of sets, naturally. First of all, what are the concepts in crisp sets or your normal sets? Equality of set is the very first concept whenever you discuss your conventional sets. Once the imprecise concepts of everyday language are expressed in terms of sets, where now the sets have elements of the form, the name slash the associated degree. But anyway, these are your conventional sets. Fuzzy sets is just a nomenclature in order to show the degree, but otherwise their behavior should be just like crisp sets. Now in the case of crisp sets, what are the various relations and operations we discuss in general? First relation which we discuss in the case of crisp set is equality of two sets. Then we discuss the various operations like complementation, intersection, union and all that. So one by one we take first of all the concept for crisp set, then the corresponding concept for fuzzy sets and so on. So first of all we know the equality of sets by definition, which is taught in 7th or 8th standard also, that every element of A is an element of B and every element of B is an element of A, then the two sets A and B are said to be equal. So in this particular case, you can see every element of A is an element of B and vice versa, though there are repetitions and this rearrangement also. But still A and B are said to be equal. However, here there may be some difference, that is element 1 is repeated twice and in some cases we don't take it as set, but just for the sake of explanation I have said that the elements may be repeated, still the size of the set doesn't become large. Similarly, you know the subset also. In this particular case you can see that B is a subset of A, however C is not a subset of A because the element 8 occurs in C which is not appearing in A. So intuitively we understand what is meant by equality of sets and subset. Now similarly we know the meaning of what is meant by belongs to and all that. Now we'll come to the corresponding definitions. And we have already considered the example of Mohan, Sohan, Johan, Abdul, Ibrahim. This is called the universal set for fuzzy sets. And various degrees are associated with these persons in this particular set, which is a crisp set, in order to express a fuzzy concept. Now, we explain the concept of equality of fuzzy sets. I think by this time you must have guessed when two fuzzy sets should be equal. That is, if the same name appears with the same associated degrees. That A is the set in which Mohan has degree 0.2, Sohan 1, Johan 7, etc. Similarly, in the B set, Abraham has degree 0.4, Mohan has degree 0.2, Sohan has degree 1, and Johan has 0.7. So the orders are different, but you can see that same persons with associated degrees are same. And therefore two sets A and B are equal, and I think it corresponds to our intuition also. So the concept of equality which prevails in crisp set or conventional set is extended to the equality of fuzzy sets. Please look at. Now you can see, in the case of set C, same elements appear, but the degree of Abraham is 0.2 in C, and it is 0.4 in A, therefore A is not equal to C. I hope now it must be clear, same elements, and not only the same elements but associated degrees also must be same if two fuzzy sets are said to be equal. Next we take subset. Again you know that set of all tall persons should be a superset intuitively of the set of very tall persons, because the set of very tall persons, every very tall person should be a tall person also. That is, the number of very tall persons should be less, and every very tall person should be a tall person also. And this guides us the definition of subset of a fuzzy set. I hope you must have guessed by this time, if the same persons appear, however the degrees are less, then the set with lesser degrees will be called a subset of the set with more degrees. This guides, and how it is expressed is available on the next slide. So we can formally describe it as, if A and B are fuzzy sets with universal set X, universal set is the set from which all the elements like Mohan, Sohan, Johan, etc. have come. And if we have A is equal to xi by vi and B is xi by wi, that is the degree of element xi is wi, then we will say that B is a subset of A if the associated degrees of elements in B is less than equal to the corresponding associated degree of the elements in A. In this example, you can see A and B are there. The degrees of Mohan are equal in the two sets. However, the degree of Sohan in B is less. Again, degree of Johan is same. Abdul is same. Abraham, again, the degree of Abraham in B is less than, and therefore we can say B is a subset of A. Here you can take B as the set of very tall persons, A as the set of tall persons. And you know, every very tall person is a tall person, therefore the set of very tall persons should be a subset of the tall persons. And this clarifies the notation also, the justification for the notation also. What is the difference between the normal set and a fuzzy set is, for example, if you look at A, it is not a set of Mohan, Sohan, Johan, Abdul and Abraham. It is not. It is a set of the names associated with degrees. Mohan is associated degree 0.2. Sohan is associated degree 1, and so on. And once the elements are expressed in this form, then it is representing a fuzzy set. It is not a normal or crisp set. I now hope that you understand how a fuzzy set is represented. And I have told you that this is being done. Why we are taking the problem of doing all this business is because we want to express the imprecise concepts like tall in terms of mathematical entities like sets. And once these are converted in terms of mathematical entities, it is easier for the computer to operate. And now we are telling what operations it will be applying in order to solve problems. And the very first relation I am describing is that when two sets which are fuzzy sets are equal to each other, then I expressed when a set is said to be a subset of another fuzzy set. This I have expressed. If we go ahead, then we'll find out how the intersection of two fuzzy sets is found, how the union of two fuzzy sets are found, how the other operations on crisp sets are simulated for fuzzy sets. That is what is the rest of the discussion meant for. We have only seen B is a fuzzy set of A, because now we have said a fuzzy set B is a subset of a fuzzy set A. If the same names appear, however the degree in the subset should be less than equal to the degree in the main set, then this B is called a fuzzy subset of A. We know that corresponding to belongs in crisp set, the word or the phrase belongs to has been replaced now by degree of membership. And one more thing we may be noting, that every crisp set may be represented as a fuzzy set, but not conversely. You can see from the next example. Now A is the set of those elements or human beings out of the 5 persons which we are considering who are at least graduates. So the crisp set will be Mohan, Johan, Abdul, because they are at least graduates. In this particular case, because Mohan, Johan and Abdul are graduates, and the set of crisp sets consists of Mohan, Johan, Abdul, but rest of the people are not graduates, so they are eliminated in the conventional method of sets. So the conventional set can be expressed as a fuzzy set in the sense that whatever element is there in the crisp set is associated degree 1, and whatever element is absent is associated degree 0. Therefore, the crisp set Mohan, Johan, Abdul has become the crisp set Mohan with degree 1, Sohan with degree 0, because Sohan is not a graduate, is not present in the set A. Johan is again having degree 1 because Johan is a graduate. Abdul is also a graduate, so the degree associated with Abdul is 1. And Abraham is associated degree 0 because Abraham is not in the set of A of graduates. So what I mean to say, every crisp set can be thought of as a fuzzy set, but every fuzzy set may not be thought of as a crisp set is clear from the next example. We here take degree of education of the people, that whosoever has a PhD degree may be called as degree of education 1. Those who are master's holders, they may be said to be educated of level or degree 0.85. Next is degree of education which we associate with a bachelor may be 0.6. Degree of education with 10 plus 2 we associate is 0.4. Degree of education which we associate with the 8th standard is 0.1. And degree of education which is associated with a person having education less than 8. Now this is a fuzzy set. Those elements which are present in the set are associated at degree 1. And those elements which are missing from the set are associated at degree 0, and hence every crisp set or ordinary set can be thought of as a fuzzy set, but the converse is not true. For example, if you associate degree of educatedness with a PhD as 1 and with a matriculate as 0.1 or something like that, and a degree of education with a 10 plus 2 level person as 0.4, then this set cannot be expressed as a crisp set. For example, the set C, Mohan is having degree 8.5, Sohan who is just a 10 plus 2 is having degree 0.4, Johan who has a bachelor's degree is associated 0.6, and so on and so forth. Now this set cannot be expressed in terms of crisp set because the associated degrees have to be eliminated, and once the degrees are eliminated, the very rational, we cannot know who is educated and who is not educated. In this particular case, the associated degree and the elements are there. If you remove the degrees and keep only the elements Mohan, Sohan, Johan, Abdul, Abraham, then it is called set of sport also. Now in the case of set of, that was called universal set. In the case of set of sport, We just want to carry on our intuition of belonging or not belonging. And you know, a person having degree 0 actually is nominally present over there, otherwise he should not have been present. For example, Abraham cannot be said to be educated at all because he is less than 8th class pass. And will not like to keep Abraham in this set, but because fuzzy set compels us to associate some degree, so set of sport says that as pass those elements which have degree 0, and therefore set of sport consists of only 4 elements: Mohan, Sohan, Johan, Abdul. What does this mean? These are the elements which have non-zero degrees. What is intersection in crisp sets? Please recall it. Intersection of two sets is the largest set contained in both the sets. Please recall, A intersection B is the largest set which is contained in B as well as in A. Now what is the corresponding of this? The correspondence of intersection of two fuzzy sets says that intersection of two fuzzy sets is the set of all elements with associated degrees, the minimum of the two. And the union is in which the degrees are which are larger. I just recall A union B is the smallest subset of X containing both A and B, containing both A and B. A intersection B is the largest subset of X contained in both A and B. So corresponding to this, we have the concept union of two fuzzy sets is the set of all those elements in the degree of any element B equal to maximum. And intersection of two sets is the set of all those elements in the degree associated with each element is the to minimum of the degree. Let us clarify it through an example, please. Now these are the two sets before us. I want to tell what is C union F and C intersection F. In the C union F and C intersection F, the degrees are taken either the minimum or maximum as is shown on the slide. These are the references, please. Chapter 5 of Fundamentals of New Artificial Intelligence Beyond Traditional Paradigm for Toshinori and Monikata, a first course in fuzzy logic by Tu Huang and Albert Walker. However, for your purpose, our two books, one by Peterson and the other by Alain Reich, will be more than sufficient. So with this, I hope the concept of fuzziness must be clear to all of you. Thank you.